This is lesson for day 117, Pascal's triangle. So the goal for today is you'll be able to expand binomials using Pascal's triangle. So remember from before, oops, sorry about that. Remember from before that we had a problem like this, a plus b squared. And you've done this since Algebra 1. Eyes up here. So this is the same thing as saying a plus b times a plus b, right? And then you did this thing called foiling. Remember this whole thing? You worked out the problem. It looked like this. You remember doing all this work? Raise your hand if you remember this. Okay. What happens if there's a problem like this now? Eyes up here. So when we have a problem like this, a plus b to the 5th power, isn't this the same thing as doing all of this work? A plus b times a plus b times a plus b times a plus b times a plus b. And when I have to FOIL these two together, and then FOIL these two together, and then multiply it all out, right? Doesn't that add a lot of work? Okay, so Pascal's triangle helps us to do this more quickly, okay? And I'm going to talk to you about how we can multiply it quickly, but you have to stay organized when you do this process. Okay, so these are the steps in Pascal's triangle, and of course some of the things you noticed. If you're in the class, we said the two sides are all ones, right? We also said that two boxes, when we put like 1 and 2 together, it's equal to 3, right? And we could do that all the way down. We could say 4 plus 6 is equal to 10, right? 10 plus 10 is equal to 20, right? And then the other thing someone noticed in here is that when we look diagonally, we have all the numbers, right? 1, 2, 3, 4, 5, 6, 7. Or we could look at that the other way, same. Or someone else noticed that, hey, look, when you add the numbers across, you get the sums of digits that are doubling, right? You'll see that? Does that make sense, everyone? Okay, so a lot of great stuff here. Okay, so I'm going to show you a couple problems. Eyes up here right now. So multiply. So in this problem, you could do this the hard way and multiply it out, or you can do it using Pascal's. Okay. So we have y plus 4 all to the 4th power. And we can use Pascal's because it's a binomial. We have two terms. We have a y and we have a positive 4. Okay. Two terms is a first and a second term. Then I notice that there's a this is positive y, by the way. There's an exponent of 4. Okay. So this is where Pascal's comes handy. Okay. So let's all look at Pascal's chart on here. We want to go to the 4th level. The top level is 0, then it's 1, 2, 3, and 4. And just look at the second number right here. You see how it's 4? Okay? These are going to be my coefficients. 1, 4, 6, 4, 1. Okay, so I'm going to take this row. I'm going to take this row and copy it. And I'm going to leave a little space when I copy it. So 1, 4, 6, 4, 1. And I'm leaving a little space in between each of these numbers, okay? Because I'm going to do some other work here, okay? Then I look at my first term, which was a y, okay? This is y, and it's being raised to the 4th power. So eyes up here. I'll use a different color so you can see it. I take y, and I'm going to start with y to the 4th, and then I'm going to write y going on as descending order. So we have y to the 3rd here. Then I'm going to write y to the 2nd here. I'm going to write y to the 1st here. And then y to the 0 here, okay? Notice that all my y's are going in descending order. My first term is going in descending order. Do y'all see that? Okay, it's all a pattern, so just want to make sure you're following. Then my second term is positive 4. So I put positive 4 here. At the end, it's going to start with 4 to the 4th, okay? So now I'm going to go descending order in the opposite direction. We got 4 to the 4th there, 4 to the 3rd here. 4 squared over here, and then we got 4 to the 1st and 4 to the 0. Okay? So another way to look at it is you could go descending order this way, or you could go ascending order starting at 4 to the 0. You just take the second term and you make it go in ascending order. Okay? When I simplify each of these each of these expressions are going to become my final answer. Okay? So here we go. What's anything to the 0 power? 1 times 1 is? 1 times y to the 4th is? No, y to the 4th. Right? 1 times 1 is 1, 1 times y to the 4th is y to the 4th. Good? Okay? Next one, 4 to the first. 4 times 4. 16 times y to the third. And it's positive 16y to the third. So our final answer was positive, so I want to make sure I put that plus sign there. Good. Keep going. 4 squared. 16 times 6. 96. Okay? And y squared. Then we got 4 to the third. 4 to the third is 64. 64 times 4 is? Nope. 256. You're on your way. That's good. That's okay. 128 is half of 256. And then y to the first, which is y. And then, of course, 4 to the fourth. 4 times 4 is? 16 times 4?
64.
64 times 4?
We just said
256, right?
genius.
Oh, it's not 64. What am I talking about? 256. And that's it. That's your answer. That's number 1. Okay? Does that make sense, everyone? So is this easier than multiplying it all out? Definitely. Does it take some organization, though? Yeah, okay. I'm going to do this one more time for number 2, okay? So number 1 was to the power of 4. Number 2 will be to the power of 6. Yes, sir? Because that's just what you have to do. Yeah, that's the way the pattern works. Yes?
Does it matter if you do it like, if you were to put y, start y4 to the right, and then start 4?
It does, yeah. The first term has to be first y. So the first term was y. The second term was 4. So, yeah. I guess, you know what, it doesn't matter. It doesn't matter what order. I changed my y. Couldn't we write this as 4 plus y? Yeah, we could have. What matters is that they're opposite, though. So you can't have y to the 4th and 4 to the 4th here at the same time. Here's one more trick. That's a good question. Do you notice my exponents here? What do they always add up to? Look, what's 4 plus 0? 3 plus 1? 2 plus 2? 1 plus 3? Right, isn't this 4 here? Y'all see that? Okay, yes, it all. Oh, okay, 4 to the 4th. 4 times 4 is 16, times 4 is 64, times 4 is 256. 256 times 1 is 256. I also know y to the 0 is 1, so 1 times 256 is positive 256. Okay? Good? Let's do number 2. So number 2, we got u plus 2 to the 6th power. Okay? So, I'm going to multiply this, so I'm going to use Pascal's to help me out so I don't have to do as much work. So I'm going to go to the 6th row of Pascal's. Ready? Let's all look at Pascal's. What are my coefficients for 6? No, we start with 1. 1, 6,
20,
15, 6.
Okay, good. So I have to write all this down. Ready? So we're going to do this along with me because it's going to take a little while. So I'm going to write these down, leaving a little space. Okay? What's my first term in my binomial? U, okay? And it's a positive u. So I'm going to start with u to the 6th. Ready? I'll use a different color so you can see it. U to the 6th, u to the 5th, and all in descending order. Y'all see that? Okay, what's my second term? What's my second term in my binomial?
2.
2. Okay, watch this. Instead of going from right to left, watch this. I'm just going to start with 2 to the 0, 2 to the 1st, 2nd, 3rd, 4th, 5th, and 6th. Okay? Doesn't that look pretty? Look at those colors. Yay, I love colors. Okay, cool. It's my favorite. Okay, so looking over here, 2 to the 0. Now we're going to start simplifying this. 2 to the 0 is 1. 1 times 1 is 1. Times u to the 6th is u to the 6th. Then we got 2. 2 to the 1st is 2. Times 6 is 12. Times u to the 5th is 12. Positive 12 u to the 5th. Okay? Then we got 2 squared. 2 squared is 4. 4 times 15 is 60. 60 times u to the 4th is positive 60 u to the 4th. Then we got 2 to the 3rd is 8. 8 times 20 is 160. 160 times u to the 3rd is positive 160 u to the 3rd. And then we got 2 to the 4th is going to be 16. 16 times 15 is 240. 240 times u squared is positive 240 u squared. And then 2 to the 5th is 32. 32 times 6, what did I get earlier today? 192 times u to the first is 192u, and 2 to the 6th is 64, times u to the 0 is 1, so it's going to be 64 times 1 is positive 64. And that's it. Okay? So is this harder or easier than multiplying it all out? It is easier, right? So this is something you do need to know how to do. It's just a pattern, right? And we can do this because math is all about patterns. Once you understand the rules and the patterns, you're like, cool, I can apply patterns to make things, do things more quickly. Okay, so since these are numbers 1 and 2, I want to hear a little talking today. Someone tell me a random number between 1 and 4. Quick. 3. Okay, 3 was first. Okay, so 3s will go first. 3s will go first, and since I heard 2 second, 2 will go second. So 3s will talk about number 1. To the rest of the group, teach the rest of the group number 1. And then 2s will teach the rest of the group about number 2. Ready, set, go. Here we go, next one. Okay, number 3. Number 3 is negative 4 to the second, negative 4 to the third, and that's it. Okay. Oh, there's your answer. Dang it. That's not what I wanted. Okay, so this is the way you set it up. Sorry about that. Okay, so be careful. Now look at this one. I'll just help you out to do one of them. Let's just go to this one. Negative 4 to the first. What's negative 4 to the first, everyone?
4.
Negative 4.
Negative 4. What's negative 4 times 3?
Negative 12.
What's negative 12 times u squared?
Negative 12.
Good, so you're going to write down negative 12 u squared, right? Now, they're not all negative. What's negative 4 squared?
Positive 16.
Positive 16. Positive 16 times 3 is? 48. 48 times u is? Good, positive 48u. So finish up my problem for me.
Is better. Photomath is kind of like special kind of pictures.
What does special mean?
It means that it's laughing. It's kind of like a satire, because you know when you hear the word special, you think like, oh, that's probably like something that's unique. But I added.
Be careful what you're saying.
Huh?
What's the answer? Someone raise your hand and volunteer. Victor's got it. Victor, go.
I can try. Okay. Negative u3 minus 12u squared plus 48u minus 64.
Okay. Let's look at this first term. What's anything to the 0 power? 1. So what's 1 times 1? 1 times u to the third? Oh, it's not negative, right? Good. And then the last term is negative 64. Yeah, what's up, David?
Why is there no u on 64?
Good question. U to the 0 power is?
1.
1. So 1 times 1 is?
1.
Then we have negative 4 to the third is negative 64. Negative 64 times 1 is just negative 64. Right? Anything to the 0 power just makes it turn into 1. Good question. Yes?
If it's to the third, how come there's 4 numbers?
It's a good question. If it's to the third, why is there 4 numbers?
Oh, because it's 0 if you want to.
Yeah, if you look at Pascal's, there should be 4 numbers as your answer. Okay, good question. Look at the beginning, Thomas. Look over here. Remember doing this problem at the beginning? Remember doing this in Algebra 1? How many terms were in our final answer?
4.
It's a plus b squared. How many total terms are there at the final answer?
3.
3. But it's a plus b squared, right? Really good question, because then you know, like, okay, if it's squared, then I should have one more, or add 1 to 2 to get that many terms. Okay? Anyways, that's the end of the lesson for today. That concludes it.